Now on to our first presentation. We've all seen the memes, right? About how the cloud is just somebody else's computer. Funny as it is, it also points to the very true fact that the cloud has a surface attack area, just like all computers do. When it comes down to it, there's a plethora of challenges both on the attack side and on the offense side of things. I'd like to introduce you to Cristian Cornea, who is a penetration tester and a security researcher, and he's here to talk to us about all the aspects of cloud security. Cristian, we're ready to hear all about it.
Thank you. Thank you very much for the introduction. I'm glad that you are all here today. I hope that you had a good break because we'll touch a very tough subject about cloud security. Let me share my screen really quick. Okay, it is all right. So we'll speak about offensive and defensive sides of cloud security. I'm Cristian Cornea, a pen tester, and my passion is to break into things, especially, let's say, hype technologies such as cloud. And let's begin. Let's see a brief introduction into cloud security. What is cloud? Many people have this question, and I have a simple definition for cloud. Uh, Cloud is a collection of resources that can be accessed within the internet. Basically, IP addresses, hosts, servers, everything that can be accessed from the internet, from your pocket, especially within your mobile phone, and that you don't have to connect physical to those resources. There are multiple cloud deployment models. Uh, One is private cloud, which is basically your infrastructure, your cloud, deployed on premise, and just you have access to this. Then it's public cloud, which is offered by many vendors nowadays, such as Amazon, Microsoft, Google Cloud, and so on so forth. Then we have hybrid, which is a combination of private and public cloud. And let's take a look at why people are moving nowadays into the cloud. The first reason basically is mobility. We can access the cloud from any device and from anywhere in the world while we have an internet access. Then we have scalability. We can scale our resources very fast based on our needs and requirements. Then we have risk transference from a security point of view, because we are not responsible anymore for some parts, some components of our infrastructure. This case applies when we are moving to a public or hybrid cloud. When we have a private cloud, there is no risk transference. We are responsible entirely for our cloud. There is a big difference between cloud versus on-premise. Basically, cloud is like ordering something from a restaurant. So it's already prepared, already done for you. And on-premise, it's like cooking the meal yourself. So you need ingredients, you need dishes, you need the skills to make that meal. So yeah, that's basically an analogy of cloud versus on-premise. And there are multiple types of cloud services. let's walk through some common types of cloud services. We have infrastructure as a service, such as Amazon AC2, uh, where they give us the servers, the virtualization, all the infrastructure, and we can scale that. Then we have platform as a service, which is used mainly for software development, like Heroku, and we have software as a service. For example, Slack, which are basically all the applications and software that we are using nowadays, like Zoom. Zoom is a software as a service, for example. Okay, we discussed a brief introduction into those cloud services, but we have here security risk related to each cloud service. We have basically different and various risks for each one, because each cloud service comes with different responsibilities for us, and different approaches, different features, different resources, and so on and so forth. So they are basically different. In infrastructure as a service, let's take some common risks for this cloud service. We have some misconfiguration at the services level. So maybe we have wrongly configured an file transfer on one of our server that is deployed in a infrastructure as a service model. We have probably exposed some critical protocols, like remote desktop access with anonymous or guest access. There are the risk of exploiting the out of dated environment, because in infrastructure as a service, we also have to be very careful, because we have a much greater responsibility than platform as a service and software as a service. We have the infrastructure security responsibility. So we must be aware that those are not managed by our cloud service provider, and we manage the infrastructure layer. So we must keep it up to date. We must keep operating systems up to date in order to prevent exploitation of known vulnerabilities that have been found on older operating systems. Then we have the risk of denial of service or distributed denial of service for network and transport layers, because we are also responsible for the traffic management. In a platform as a service, the risks are not so higher than infrastructure as a service, because our responsibility was shortened. Basically, there is a possibility of injection of backdoors in software that we develop through a platform as a service. We have virtualization risks, and a very big issue with platform as a service is that there are possibilities of exploiting the missing access controls. So some platforms as a service comes by default with unrestricted access controls. So we must define a good role and access based metrics. So we will give people only the required permissions and privileges that they are in need to complete their everyday tasks. This is basically related to principle of least privilege. Then we have software as a service risk, which is basically, as we described previously, is composed of all the applications, not all, but almost all the applications we see every day. We must be very careful what code we put on a software as a service model, because we may place there some vulnerable or misconfigured code, and that will permit attackers to just gain access to the underlying infrastructure, underlying layers of the model, because we just misconfigured something or did not implement best practices when comes to code development. So we have web-based exploitation threats. So basically, just be aware that developing secure applications in a software as a service model is our responsibility. Then we have also virtualization threats, like in platform as a service. And we have application layer denial of service, because in a software as a service, as a conclusion, we are responsible for the application layer. Let's move to a more interesting topic. Let's see some black box attacks on the cloud. So unauthenticated attacks on the cloud. But first, let's define the differences between penetration testing on cloud and security audit on cloud. Penetration testing on cloud is basically the process through which we apply our hackish methodology to find vulnerabilities on the actual cloud deployment. And we go from an external unauthenticated perspective, and we must see how far we can go. When a cloud security audit is basically meant to check some configurations of the cloud platform. For example, in Microsoft Azure, we can do a cloud security audit using CIS benchmarks, and that's just a cloud security audit. It's basically done from an authenticated high privilege level, and we just check buttons, and we just check if best practices are in place for the cloud deployment, without actually exploiting those, or without actually finding ways to exploit those. So how can we do a cloud security audit? It's very simple. We can do it through CIS benchmarks. We can take a look at the CSA cloud controls metrics, which defines some best practices for developing a good and secure cloud. And we have some automation that can be very, very, very helpful for us. We have tools and resources that can be found on GitHub or on this link. Okay, so let's move into the most interesting part from this presentation. We have black box cloud pen testing, and how can we do that? Most common cloud pen testing methodologies are, and also, let's say, bug bounty methodologies on the cloud are the following. Basically, we can enumerate public cloud storage, such as Amazon S3 buckets, Google buckets, Azure blobs. We can use Google Docs for that one, and we'll have a slide where we'll present how to do that with Google Docs, and we'll actually do that. And very important, we have to search GitHub repositories and the internet for cloud secrets leaks. You can do that with this tool, Git leaks. Then we have password spraying on cloud accounts, and of course phishing for admin console access. So we phish users to get access to their admin uh, console. And also we have a method, even if you say, okay, how can we phish admin accounts for their access if they have MFA in place? It is a very simple way to do that. We have a specialized tool to do that, to get also the access token into the cloud admin console, even if the accounts are using MFA, and we'll look at that a bit later. Okay, so we talk about the phishing on cloud accounts to get admin access to the cloud console. And here we have Evil Jinx 2, which is a tool that help us to do phishing and even to bypass MFA to get access. The concept is very simple. It will, instead of capturing the credentials, it will capture access tokens, so the session tokens of the users. And we can just copy paste the session token into our browser and having all the access we need for the admin console. And how we can do that? Firstly, cloud-based phishing is very simple because we have a lot of domains to choose for. In this example, I took, for example, 3 domains that I found that online that are available for purchase, are very good domains that we can do in our phishing assessments for cloud credentials. And then we can just use Evil Jinx 2 to get credentials and to get the session tokens and to bypass the multi-factor authentication. Okay, so then we have another attack vector, very interesting, which is cloud-based subdomain takeover. Basically, on cloud, we have multiple services. Okay, we have, for example, Azure Traffic Manager, which allows us to basically make redirects, view logs of the traffic, do load balancing, so on and so forth. We have the storage buckets for Amazon. We have the CloudFront CDN, and we have some Azure default web domains that is related to the Azure web development part. Here, for some domains takeover, it happens that our targets have CNAME records pointing actually to those services without having them registered. So, okay, maybe a CNAME record was left there, and we we don't have it anymore. So, yes, let's start with the demo. We will have a subdomain to target to see if we can execute a takeover over this one. So let's see the CNAME records for our target subdomain, which is demo.defcamp demo.online. Yes, so we have here the subdomain with the CNAME record that is pointing to the traffic manager endpoint. And we can define this traffic manager endpoint into our Azure console to take over this subdomain and to make redirects to any domain we want. We can even create a server and make the redirect there. So we'll have almost complete control. But firstly, we must validate if this traffic manager endpoint is taken or not taken. Let's check. Okay, I'll copy it. Here is the Azure console. We will go to traffic manager. Just a bit. Okay, it is loading. Good. So no profiles defined. We'll go traffic manager and create. Wait a bit. Come on. Okay. And here we'll input our endpoint. And as you can see, the traffic manager endpoint is actually available. The routing method will be performance. This is our subscription. And we have already created a resource group. And we'll do create. We wait for our traffic manager profile to be created. Okay, it's deployment in progress. Wait also a little bit for it to be successfully deployed. And here we are. We go to the resources, and here is our traffic manager console. We go to settings, endpoints, and click on add new endpoint. And if we have an endpoint defined in Azure, okay. But in this case, we don't have an endpoint already defined in Azure. So we have the possibility to redirect to an external endpoint. We'll put something like test, okay. And for example, we want to redirect to google.com, location, no important, and add. We wait a little bit. Let's see where it is our here, and we navigate to the domain. It is loading, and here we are actually on the Google page. It's doing a redirection on the Google page. As you can see, we have successfully take over this domain through traffic manager service, but also let me go back to the presentation. But also we have multiple services. Just have to research a bit. Yes, this is the previous slide. There were multiple cases in which attackers were to take over subdomains through storage buckets, endpoints, through.
I'm going to do right now in order to wrap up the demo that Christian performed earlier is to ask him for one key takeaway that all cloud app developers should adhere to.
Thank you. So, firstly, you should take basically cautions for data and storage approaches on cloud, and accounts. You should have multi-factor authentication.